So at this point you've done limiting reactant problems, but now what's a procedure for how to conduct a excess reactant problem? So how much excess reactant would remain upon the completion of a reaction with 124 grams of aluminum reacting with 601 grams of iron 3 oxide? Well, stoichiometry works for products, reactants, looking at reactants relative to each other, products relative to each other. So a way that you can do this is just pick one reactant. I'm going to pick aluminum and do the stoichiometry to see how much iron oxide is needed. So I've got 124 grams of aluminum. The molar mass of aluminum from your periodic table is 26.982 grams, 1 mole. And here, 1 mole of the iron 3 oxide, again that 3 is the oxidation state of the iron, react for every 2 moles of aluminum. Resize. Give myself some more room. And then the molar mass of the Fe2O3 is given. It's 159.7 grams, or 1 mole. And if I do that math correctly, I get 367, for round to 3 sig figs, grams of Fe2O3. Now what this number means, again I'm not interested in the product here per se, I want to know how much excess remains. So I can do the stoichiometry for if I've got aluminum, I can do it for the other reactant. And this number means that 367 grams of Fe2O3 are needed. So, the question says that I have 601 grams. So, I've got plenty of Fe2O3. You have 601 grams. Therefore, Fe2O3 is the excess reactant. And the question's asking how much remain. Well, I guess the formula would be you would have the excess is going to be equal to the mass of the total mass minus the mass of what's needed. So rewrite that as total. The mass total. So the total mass minus the mass that's needed. 601 grams is given in the problem. What was calculated was 367 grams will be needed. And that's going to be equal to 234 grams in excess. And that's the process of how you do an excess reactant problem. If, for example, this can be worked another way, I'd pick the other one. Let's just say I started out with my 601 grams of Fe2O3. 59.7 grams are in 1 mole. 2 moles of aluminum are needed per 1 mole of Fe2O3. And then 1 mole of aluminum still weighs 26.982 grams. So if I do that math, this is saying if I had 601 grams of Fe2O3, for it to completely react, this calculation tells me how much aluminum I would need. So do that math, and I get 203 grams of aluminum needed. But I don't have that much. This number is larger, it's needed, but only have 124 grams. Therefore, if I do this calculation first, that tells me that aluminum is limiting. That's a way of doing excess reactant problems. If I'd started with Fe2O3 and I wanted to see how much aluminum I needed, this would tell me that aluminum is limiting. Therefore, I'd have to do that first calculation, meaning first calculation. This calculation found how much excess that I have. It requires a little bit more judgment than a limiting reactant problem, but you use stoichiometry. Reactant, convert to how many grams of the other reactant you need. You either have it or you don't. This instance, you need 367, you have 601, so you have enough. This is excess. This procedure, if you start with grams of one reactant, figure out how many grams of the other reactant you need. Here, you calculate you need 203 grams. You don't have it. You only have 124 from the problem. Aluminum is limiting.